This is a beautiful problem. In this problem, you have to find integer solutions. So one equation is given, that is a square root of a plus a square root of b is equals to a square root of 2023. And then you have to find integer value of a and b. So how will you do this problem? In this case, you have two unknowns and only one equation. You can solve it by looking the problem condition. The condition is given, that is, this is solutions are integers. So this is very important. Now the solutions are integer. So basically this constraint, the solutions, number of solutions will be limited. Now if you remember the properties of root, that is, if you have root x, then this is defined only if anything inside the root is positive. This means from here I can say x is greater than 0 or equal to 0. Then only root function is defined. Now in this case you have root a and root b. This means both has to be greater than equal to 0. That is, a is greater than 0 and b is also greater than 0. But now they are also integers. This means they are natural numbers. So you have a positive integers. This means a and b belongs to natural number set. So now I can say a and b basically belongs to natural number set. So this is a condition that I have, and I will use this condition to find the solution. Now see how we should proceed. As usual, we will take one other side and then we will try to square so that we can remove the root term. So let us take b this side and then square both sides. So if you square, I will use a formula. If you remember, that is a minus b whole square. This is equals to a square plus b square minus 2ab. So if I use this formula, this becomes this side simply a, and this side a square is 2023, b square is b, minus 2 times root 2023, that is a, times root b. So this can be written as a is equals to 2023 plus b, let us take it together, minus 2 times 2023 times b. So I am using one properties of exponent, that is, if you have root x multiplied by root y, so this becomes root x by. So in this case we have used this trigonometric or rules of power. So trigonometric identity or rules of power, exponent. So now you see, a is a, as I said, a is a natural number. So this a belongs to natural number set. So this is a is a natural number. So if this means if left hand side is a natural number set, then right hand side also has to be natural number. This means this side you have these two terms, this term and this term. Both term has to be natural number. So this means this is natural number, this belongs to natural number set, and this also belongs to natural number set. And 2 is a natural number. This means product of these two things also has to be a natural number. This means the second component also has to be a natural number. This means now I can say that this term under root 2023b belongs to natural number. And now this belongs to natural number. This means this must be a perfect square. So this is natural number. This must be a perfect square. Then only it will be a natural number. This means now we can factorize 2023 and let us see what happens. So if you factorize 2023, you will have, if you take 7, it will not be divisible by 1, 2, 3, 4, 5. So from 7 you will have 289 and then it will be divisible by 17. So basically 2023 can be written as 17 square times 7. So let us plug this value. So if you plug this value here, you will have 17 square times 7 times b, and this has to be a natural number. Now take 17 outside. This means the quantity that is inside the root also has to be a perfect square. So that I can take this outside and then multiply by 17, then I will have a natural number. And this is possible only if I have 7b as 7m square, something of this form. Then I will completely find the root. For example, you can say here 7 into, and b is, this b is 7 square, not 7b. So b is equals to 7m square. So this becomes 7 times 7 square, 7m square. So this will be 7m. So in this case, you can say that b has to be a form of 7m square. And in this case, m can be any natural number. So in this case, a belongs to basically, m belongs to natural number set. M belongs to natural number. So m can be any natural number. So this we have done when we have taken b to the right hand side. So what we have done in this problem, so when we are doing this, we have moved b to this side and then we have a squared. Now the same process can be done if I move a to the right hand side and a square and use the same logic. Then in that case, what will the final conclusion? I can say in that case that a has to be 7 times some number square. Let us say call this as n. So a has to be 7n square, where n belongs to natural number set. Now let us see. So let us substitute this in the original equation. What was the original equation? Root a plus root b is equals to root 2023. Let us plug the value of a and b in the original equation. So if you will plug, you will have a is 7n square and b is 7m square, and this is equals to a square root of 2023, and this is 17 square into 7. So this will be root 7 cancelled out. So this will be simply n square plus m square is equals to 17. Because root of 17 square is 17. So this means I can say n plus m is equals to 17. Now we have very important conclusion. N plus m is equals to 17. So how many solutions are possible in this case? And n and m belongs to natural number. So this means now I can say that what are the two numbers whose sum is 17 and it belongs to natural number. So now I can say the solution for n and m will be n can be 0, then m can be 17. N can be 1, then m can be 16. N can be 2, in that case m can be 15, and this goes on. So final will be n can be 17 and m can be 0. So how many solutions? So we will have from 0 to 17, that is 18 pair of solution is possible. 18 pairs of solution. Now see, this is the value of n and m. Sorry. The value of a and b is basically 7n square and 7m square. So the a and b, again it will be 18 pair, and the solution will be, the first will be 0 and 7 times 17 square, and the second can be 7 times 1, that is 7, and then 7 times 16 square, and this will go on. So finally you will have, so this will go, and then final solution will be 7 times 17 square, and then 7 times 0 square. So these are the 18 pairs of solution that is possible for this problem. So this is 18 pairs of solution that is possible in this case. So I hope you enjoyed this video, and if you enjoy, please share with your friends, like to this video and subscribe to my channel. Thank you. I will see you in the next video.